I'm Anil Kumar, and in this video we'll further explore how to find equation of a quadratic function from given conditions. The question here is, explain how you can determine the equation of the axis of symmetry for the parabola passing through the points 3, 5 and 5, 5. Part B is determine its equation. Determine equation of the above parabola if its y-intercept is at 10. Okay, so what we are given in part A is that there are 2 points. One point is 3, 5, the other one is 5, 5. As you notice, y values are same, so they are kind of horizontally placed on the coordinate plane, correct? So, but these 2 points are on the parabola, correct? These points are, let me write down now, as 3, 5 and 5, 5. How do you find the axis of symmetry? So if we have a horizontal set of points, then in a parabola we always have axis of symmetry. That means it is definitely a line which should go midway between them, right? Perpendicular and midway between them. That is the axis. So we need to find the midpoint. That is how you find the axis. So in this case, we can find axis by finding midpoint of x values. So axis of symmetry is let us say x equals to x values. X1 is 3, the other one is 5. So it is 3 plus 5 divided by 2, which is 8 divided by 2 or 4. So this is x equals to 4. So that is how you can find the axis of symmetry when 2 points horizontally placed are given to you. That's important, okay? Now part B here is determine equation of the above parabola if its y-intercept is at 10. That means now we are given another point, y-intercept. That really means x value is 0, y value is 10. So that is given to us and we need to find the equation of the parabola, right? So how can you find it? Since we know axis of symmetry, we can actually begin by the vertex form and find the equation. We can write this as y equals to a times x minus axis of symmetry, which is 4, whole square plus k, right? That should help us to get the equation using one extra point which we have 0 and 10 given to us, right? Now what we can do now here is we can write down the equation substituting the point, one equation. The second equation we can write using already given points, one of them, right? So let us use these 2 points. So first equation, let me write using 0 for x and 10 for y. So we get 10 equals to a times 0 minus 4 whole square plus k. So that gives us 10 equals to 16a plus k, right? So that is one equation we have. The second equation, we can use one more point. Since there are 2 unknowns, do you see that? So we need 2 equations. So this time, let us use the point 5, 5 for example, okay? So that means x is 5, y is also 5. So we get 5 equals to a times 5 minus 4 whole square plus k, and 5 minus 4 is 1. So we get 5 equals to a plus k, right? So let us call this as equation 2, right? So we have a plus k as 5 and 16a plus k as 10. So if we have to solve, we can subtract one from the other, right? So let us do equation 1 minus equation 2. So equation 1 minus equation 2 means 10 minus 5 is 5 equals to 16a minus a is 15a and k minus k is 0. So 15a equals to 5. That gives us the value of a, right? So let's further move to the right and solve. So 15a equals to 5 means a equals to 5 over 15 or 1 over 3, right? So we get a equals to 1 over 3. Since we know a, we can use our equation number 2 again and find k, right? So k is equals to 5 minus a, or 5 minus 1 over 3, which is 3 times 5 is 15 minus 1 over 3, or 14 over 3, correct? So we know the value of k also. Knowing both a and k, we can write down our answer, which is y equals to a is 1 over 3, so we get 1 over 3, x minus 4, let me push it a bit, and k is 14 over 3 plus 14 over 3. So that is how you can find the equation of the quadratic function given the conditions. I hope that helps. Thank you and all the best.